In this video, we'll be going over properties of exponents. These properties help us simplify and evaluate exponential expressions. In the properties that we'll go over here, we'll use various letters. For these properties, let's assume that a and b are non-zero numbers. Our first property is that if I have a to the power of 0, this is equal to 1. For example, if we have 5 to the 0th power, this is equal to 1. Our next property tells us that if I have a raised to the power of negative m, then this is the same as 1 over a to the power of m. As an example, consider 5 to the power of negative 2. This, according to our property, is the same as 1 over 5 squared, which we can simplify to 1 over 25. Our next property says that if we have a to the power of m and we multiply it to a to the power of n, then we can combine these exponential expressions together to get a to the power of m plus n. For example, if I have 5 squared times 5 cubed, this is going to be 5 to the power of 2 plus 3, or 5 to the 5th power. This is because we have 2 copies of 5s here and 3 copies of 5s here, so if we count all the 5s we have together, there's 2 plus 3 copies of them. Our next property is similar to our previous one. If we have a to the power of m, this time instead of multiplying, if we divide by a to the power of n, then we can combine these expressions together into a single exponential expression, a to the power of m minus n. As an example, let's say we have 5 to the 3rd power divided by 5 squared. According to our exponential property, this is 5 to the power of 3 minus 2, or 5 to the 1st power. This is because if we have 3 copies of 5s in the numerator and 2 copies of 5s in the denominator, well, 2 copies of 5s can cancel out from the numerator and denominator, leaving me with 3 minus 2 copies of 5s. Our next exponential property says that if we have a to the power of m and we raise this whole expression to the power of n, this expression can be simplified to a to the power of m times n. As an example, let's say we have 5 squared and I want to cube this whole expression. Then, according to our property, this simplifies to 5 to the power of 2 times 3, which gives us 5 to the 6th power. This is because when we cube 5 squared, we're basically taking 5 squared and multiplying it to itself 3 times. So essentially we'll have 3 groups of 2 5s. And so altogether we'll have 6 5s. Our next property tells us that if we have a times b and we raise this to the power of m, our exponent can distribute to each of the factors. We'll end up with a to the power of m times b to the power of m. For example, if we have 5 times 7 and I raise this to the 3rd power, this essentially is 5 times 7 multiplied to itself 3 times. Well, we'll have a total of 3 copies of 5s and also 3 copies of 7s. So that's why this simplifies to 5 to the 3rd power times 7 to the 3rd power. Similarly, if we have a divided by b and I raise this to the power of m, again this exponent can distribute to both the numerator and denominator. We'll end up with a to the power of m divided by b to the power of m. So for example, let's say we have 5 divided by 7 and I raise this to the 3rd power. This in essence is 5 over 7 times itself 3 times. So if we collect all of the 5s in the numerator, we'll have 3 copies of 5 in the numerator, so that's 5 cubed. And if we collect the 7s in the denominator, we have 3 copies of 7s, so that's 7 cubed. So again, our exponent here distributes to both the numerator and denominator. The last property of exponents that we'll go over deals with fractional exponents. If I have a to the power of 1 over m, this is the same as the mth root of a. So for example, if we have 8 to the power of 1/3, this is the cube root of 8, which is 2, because 2 multiplied to itself 3 times gives us 8. So those are the properties of exponents that you should be aware of. You can use them to help you simplify or evaluate exponential expressions.